Hey everybody. Today we're doing a short review of angles and angle measure. An angle is just a visual representation of a rotation. Here's a few examples. In each of these cases, you should imagine starting with one of these rays and turning it until you get to the other. Every angle consists of a vertex, that's the point that you're rotating around, an initial side, where the rotation begins, and a terminal side, where the rotation ends. The measure of an angle is just the amount of rotation needed to bring the initial side to the terminal side, always measured in the counterclockwise direction, like I have indicated here. Now, there are multiple ways to measure that kind of turning. The most elementary is the degree. There are 360 degrees in a full rotation, and so there are 180 degrees in an about face, a half rotation. Here's a few examples of some angles measured in degrees. Each one of them is drawn in what we call standard position. The vertex is at the origin, and the initial side is on the x-axis. So here I'm showing you 30, 45, 60, and 90 degree angles. Here are some angles with larger measures, 120, 135, 150, and 180 degrees. Again, you can see 180 degrees is a straight angle, an about face. Negative angle measures correspond to clockwise rotations. So here you see rotations of negative 30, negative 45, negative 60, and negative 90 degrees. So going in the opposite direction as before. Starting in calculus, angles are almost always measured in radians, not degrees. There are 2 pi radians in a circle, meaning that the measure of a straight angle is pi radians. At first, this is very frustrating that there's an amount of radians in a circle that is not an integer, but isn't even rational. But with just a little bit of practice, this is actually the better and easier way to go. The reason is because that we frequently describe the measure of an angle as a fraction of pi, and therefore we're describing the fraction of a straight angle that we're dealing with. For instance, 1/2 pi is half of a straight angle, or a right angle, 90 degrees. And 1/4 pi, or pi over 4, is a fourth of a straight angle, or 45 degrees. If we need to switch from degrees to radians, or from radians to degrees, we have a couple of formulas. You take the number of radians, you multiply by 180 over pi, you get the number of degrees. Or you take the number of degrees, you multiply by pi over 180, you get the number of radians. The way I remember this, the first one, for instance, is since radians usually have a pi in there, I think about the pi canceling, the pi and the radians canceling with the pi in the denominator of the of the 180 over pi. There's another reason why radians are a great way to measure angles, and it has to do with arc length along a unit circle. In a circle of radius 1, that is to say a unit circle, an angle with measure theta radians subtends an arc of length theta. In other words, it corresponds to an arc of that same length. In calculus, we learn all sorts of formulas for limits, derivatives, and so on, and they all depend on this fact right here. If we're not measuring our angles in radians, the formulas don't quite work. We can take that last fact and extend it to circles with radii other than 1. In a circle of radius r, an angle with measure theta subtends an arc of length r times theta, so it just scales up linearly. There's a lot of vocabulary that goes with the study of angles. Let's just run through some of it just so you have it for reference. Angles whose measures differ by multiples of 2 pi radians, or multiples of 360 degrees, are called coterminal. When drawn in standard position, coterminal angles have terminal sides that overlap because they differ by full rotations. Angles whose measure is between 0 and pi over 2, so 0 and 90 degrees, are called acute, and angles whose measure are between pi over 2 and pi are called obtuse. Here's some examples. A right angle, of course, is one that has a measure of exactly pi over 2 or 90 degrees. It's the an angle that you would see at the corner of a square or rectangle. 2 angles whose sum is pi radians or 180 degrees are called supplementary. When placed side by side, supplementary angles yield a straight angle. And two angles whose sum is pi over 2 radians, or 90 degrees, are called complementary. If you place two complementary angles side by side, you get a right angle, a total measure of pi over 2 radians. Let's wrap up with a few quick problems. Number 1. Convert 135 degrees to radians. So, using that formula from a few slides ago, we take 135, multiply it by pi over 180, simplify to get 3/4 pi. So this is 3/4 of a straight angle. Convert 7 pi over 12 radians into degrees. So we're this time needing to multiply 7 pi over 12 times 180 over pi. In this case, the pi's cancel. We get a little bit of simplification. It's 105 degrees. Problem 3. Two angles are supplementary. One has a measure of 2 pi over 7. What's the measure of the other? So the two angles have to add up to pi radians. So the second angle, theta, has to be pi minus the one that we have, minus 2 pi over 7. Pi is 7 pi over 7. So when we do that subtraction, we get 5 pi over 7. Problem 4. An arc of a circle with radius 12 centimeters has length 24 centimeters, like in this picture. Find the measure of the corresponding angle. So we're going to use this formula, length equals r times theta. We have a length of 24 centimeters and a radius of 12 centimeters. Dividing both sides by 12, we get that the angle has to be exactly 2 radians. Problem 5. Find an angle between 0 and 360 degrees that's coterminal with negative 490 degrees. So we're just going to add 360 degrees again and again and again until we get to an angle that's in between 0 and 360 degrees. Adding 360, we get negative 130. We're not there yet. We do it again, and we get 230 degrees, which is in the range we want. 230 degrees and negative 490 degrees are coterminal with one another.